Hi, everybody. So I wanted to take a little bit of a step back so we could actually see how to really dilate a triangle in this example. So we have a triangle here, little triangle ABC is being dilated by a scale factor of 1.5, whose center is at -3, -4, which I actually have graphed here. And we want the ordered pairs of the new points. So when we're dilating by a scale factor of 1.5, one of the first things you should note is that we are actually going to make the triangle, yes, larger because 1.5 is greater than 1. Anything less than 1 and greater than 0 is going to be a smaller image. So anyway, so like what we did when we were doing lines, we count, to the point, but interestingly enough, A is straight up vertically from the center of dilation. But when we go to do B, we're going to have to do a vertical and a horizontal. But let's begin with A, where we're most comfortable. And when we go up, we know that we're going to be going up 1, 2, 3, 4, 5. And then if the scale factor is 1.5, like we did with the lines, we would multiply that by 1.5 to get 7.5. So we are going to be going 7.5 units up from our center because everything comes from the center. So from here, we're going up. We already know that this is 5, and then 6, 7.5 puts us right here at A prime. In A prime, we can actually write out what that ordered pair is for A prime. You're over at -3 because the x-coordinate hasn't changed, only the y-coordinates change. And at 7.5 units up from the center puts us at 3.5. So that's going to be the first ordered pair. Now, when it comes time to do B, again, we're going to do our vertical going straight up and then horizontally straight across. So what I want you guys to do is press pause at this time and do your own calculations from here, okay? I'll meet you in a sec. 3, 4, 5, 6, 7, 8. So that's 8, and then across 5. And then times 1.5 is going to be equal to 12. And then times 1.5, we should remember from when we did A prime, it's 7.5. So again, from the center, I hope you guys got that you're going to be going up 12 and to the right 7.5. Okay, so with that said, we're going to go up, and then this is 8, 9, 10, 11, 12, and then 1, 2, 3, 4, 5, 6, 7.5, and that right there is going to be B prime. And B prime, if we were to count, we're going over 4.5 and up 8, so B prime is going to be 4.5, comma 8. And then if we do C prime, again, I'm going to use a different color. We didn't use green yet. Okay, so we'll use green. So from the center, we're going to go across from the center and straight up. And then 1, 2, 3, 4, 5, 6, 7. We're going over 7 and then up 1. And then 7 times 1.5. 7, I believe, is 10.5, right? Yeah. 7 times 1.5 is equal to 10.5. Of course it is, because half of 7 is 3.5. Okay, so that's 10.5, and then times 1.5 means we're only going up 1.5. So from my center, we're going to go out. So we're already out here at 7, 8, 9, 10.5, and we're going to go up 1.5 right there, and that's going to be our C prime. And if I look at C prime, this is 6, 7, so this is going to be 7.5, comma, -2.5. I believe I'm right. Let me double check that, right? 7, 8, 9, 10.5. Yep, okay. So, and then going up from there, so that would be, yeah, I agree. That is 7.5, comma, -2.5. Now, a couple of things to note. I'm going to draw this by hand. This is not easy to do. So I'm going to try to be as straight as I can. You're going to be much better because you're actually going to use rulers. So you guys are going to, whoops, and then just come straight across there. I kind of missed. But a couple of things we should note is, when we actually create those images, that AB is parallel to A prime B prime. BC is parallel to B prime C prime. This line is parallel to that line, which is important and imperative to see. Now, the other thing to also note is, I'm just going to erase this. Isn't this cool? Check this out. I can actually erase. Ha ha. I have a program that does this. So going along here, and I'm just going to go along there because I just have OCD, and get that out of there. We'll go back to my color. and then we'll just reconnect right over here. And again, if you remember, if you were to draw a line, remember what I said, if we were to actually create a line, which I could probably do here with some of these tools here, but I'm not really interested, is if I were to draw it, remember, I can go from A prime, and it's always going to go straight through the center. The same thing if I do B prime. And again, your rulers should do a better job than my freehand, but right now I'm killing it. Look at me go. And then C prime, again, if we go along here, ooh, they will always intersect at the same spot. The other thing to note is that if we were to calculate AB over A prime, B prime, that ratio would be equal to BC over B prime, C prime, which would be equal to AC over A prime, C prime. The things to note is because one of the important things is that, let me use a different color, is when these triangles are similar, right? Because we're saying that triangle ABC is similar, that's a little squiggle, to A prime, B prime, C prime. That means then that angle A is congruent to angle A prime. Angle B is congruent to angle B prime, and angle C is congruent to angle C prime. And not only that, it's saying not only do you have corresponding congruent angles, but the ratios of the sides are in proportion. Now, what does that mean? So what that means is, let's say that, for example, let's just play along here, that this is 3, this is 4, and this is 6, okay? Now, because your scale factor is 1.5, that means the length of this side should be 1.5 times bigger than this one, so that would be 4.5 for A prime, B prime. If you look at BC, this side should be 1.5 times bigger than that also, so that's going to be a 6. And then this is going to be 1.5 times bigger, so 6 times 1.5, I hope you guys are doing it, I believe it's 9, yeah, is going to be 9. I just want to verify. So when you do these ratios of this side over that side, or that side over that side, and you write it out, right, it's going to be 3 over 4.5. Is that equal to, 4 over 6, and is that equal to 6 over 9? And if you simplify all of these fractions should all come out to be, let me do it the other way, because in other words, well, no, this is okay. You can do 3 over 4.5 is equal to 4 over 6 is equal to 6 over 9, which you can also write as 4.5 over 3. Is that equal to 6 over 4? And is that equal to 9 over 6, right? Because I'm doing actually new over old. So, stupid thing, get out of here. So if you do this, if you simplify this, 4.5 over 3 is 1.5. 6 over 4 is 1.5. 9 over 6 is 1 over 5. These all simplify to 2/3. So this is if you're doing the old over the new versus the new over the old. But again, those ratios will always simplify to the same value. That's how you're always going to know that things are similar. This is problem 1, and we're going to move on to other stuff next.